We're going to look at adding and subtracting radicals. It's going to be really easy for you guys because it's just like adding and subtracting algebraic expressions. So I'm going to do one of those first, just here off to the side. If I asked you to, excuse me, add this, simplify this, 3x plus 4y plus 2x. Do you know what that would simplify to? Yeah, what would it be? 5x plus 4y. You already know how to do that, right? Combine like terms. Well, with radicals, it's the same thing. And so it says here, to add or subtract radicals, combine the terms with the like radicals. If the radicand is the same, then those are like terms. Just like in that example, you put the x's together. If the radicands are the same, just like if the variable is the same, then you just add the coefficients. So 2 root 10 plus 3 root 10.
5 root 10.
5 root 10. This is too easy for you guys.
Oh, easy?
5 root 10. You add the coefficients. You don't change the radicand when you're adding or subtracting. Never change the radicand. The number inside the square root sign. You're just adding or subtracting the coefficients. So for the second one, which are like radicals?
Negative 8 and 2.
Yep. These two are like radicals, so those two can be combined. 2 root 10 minus 8 root 10 is negative 6 root 10. And then the plus 3 root 5 stays there. Just like in the first example, the 4y just stayed there. This radical is not like the other two, so it just stays there as part of the answer. Add or subtract the coefficients of the like radicals. That's the rule that you're following.
I have a question.
You have a question? What's your question?
Can you like make the 5 into a 10, just like you can with that?
Here's another example. Root 27 plus 2 root 12. Which are like radicals? None, right? 27 and 12, they're different. But neither of those is simplified. So we actually have to simplify the radicals first, which is what we were doing yesterday. So simplify the radicals first. And to simplify root 27, you find the largest perfect square factor,
9.
which is 9. So this is actually 9 times 3. And what about the 12? What's the largest perfect square factor of that? 4. And this is 4 times 3. So then when we simplify 3 root 3 plus 4 root 3. So that 4 comes out as a 2, multiplies by the 2 that's already out there. So it's 4 root 3. Now we actually do have like radicals, and we can add them together. 3 root 3 plus 4 root 3, 7 root 3. You need to do that simplifying first to know whether or not they're like radicals. If you go back to the ones we did before, they were already simplified. One had a root 10. 10 doesn't have a perfect square factor. One had a 5. 5 doesn't have a perfect square factor. So we didn't have to do this step. But if you do have unsimplified radicals, then you have to do that. And here's the last one. 5 root 8 minus 3 root 18 plus root 3. And I want you to try it. Simplify the radicand. So 8 has a perfect square factor of 4. So I'm going to make this 4 times 2. 18 has a perfect square factor. 9. So that's 9 times 2. But 3 does not have a perfect square factor. So it stays like that. Then what I'll do is take out the perfect square factors. That 4 comes out as a 2. And the 9 comes out as a 3. And then I have the 5 times 2 is 10. So that first one simplifies to 10 root 2. And then 9 root 2. or negative 9 root 2 plus root 3. You may or may not write these intermediate steps, and it doesn't really matter to me whether you do or not, as long as you have what it simplifies to. And then combine like terms, so 10 root 2 minus 9 root 2 is just root 2. And the root 3, again, has to just stay on its own because it doesn't have anything to combine with.